Good morning students, welcome back to digital electronic class. In today's class we are going to start the unit 3 part, that is a continuation of the unit 3. In that we are going to design the PLD. What is PLD stands for? Programmable Logical Devices. So in today's class we are going to discuss about what is PLD. So what is PLD stands for? Programmable Logical Devices or Logic Devices. Okay, so basically before proceeding for this unit 3, we should know that what we discussed till now. So in the unit 2, we had discussed about 3 things. First thing is what? Whatever the data, whatever we do have, that one, how do we convert into code form? Code converters we have done. In that we have discussed about BCD to access 3, BCD to 7 segment display. This particular thing we have discussed in unit 2. And that we have seen the problem related to multiplexer, demultiplexer, encoder, decoder and all those things we have covered. In coming back to this unit 3, we are going to design programmable logical devices. So this is programmable logical devices is basically is what actually. So in that, what actually we are going to see? We are going to see how the storage of the information. Till now what we have done? We have done the designing part. We have talked about how do we convert it. Now in this unit, we are going to see the storage. How we are going to store it. So storing in the sense, we just want to use here the concept of memory, right? So what is memory actually? Memory is nothing but a storage device which can store a bit of information, or it can store a byte of information, or it can store a kilobyte of information, it can store megabyte, it can store gigabyte, terabyte, like that. It can store different types of size of the data. So that data size is nothing but information. So what is a memory actually? Memory is a device which can store a data. For storage purpose, we are going to see the memory. So memory is also one of the example of your programmable logical devices. So in that memory, we come across 2 things. One thing is that what is the RAM? Next is what is a ROM? So basically what is RAM stands for? It is nothing but random access memory, and ROM stands for read only memory. So this is also a memory device, this is also a memory device. So what is the use of it? Where actually we can use this particular thing? So we should know that whenever we will talk about any particular memory devices are those which can store the information, in the form of bits. So basically bits, what is the bits means? Bits is nothing but the combinations of zeros and ones. So if you combine bit, you can get the nibble. So if I want to combine 4 bits, that is equals to 1 nibble, right? So first thing that what come in your mind is nibble. So then if you combine 8 bits, then we can say it is a 1 byte. So right, this is the way we can proceed. If you want to write 1 byte into 1 kilobyte, how do we write? 1 kilobyte would be 2 power 10 bits. So that's nothing but 1024 bits is equals to 1 KB. Likewise, if you want to go for 1 MB, so if what could be the 1 MB value? It's nothing but 1024 KB. That is nothing but 1 MB. So likewise, we'll go for byte. So first we talk about bytes. This is your bytes. So this is the way the chain is keep on moving. If 1 MB, then after that 1 MB, what is the next thing? 1 GB. So 1 GB is how much? 1024 MB. If you want to go for after GB, then just want to go for 1 terabyte. So what is a 1 terabyte? 1024 GB is nothing but 1 terabyte. So these are actually what? This is the size of the storing capacity of the memory devices. So if you want to store the bit, so what is a 1 bit means? Bits are nothing but zeros and ones. 1 nibble is how much it should have? It should have 4 bits. If you're taking the 4 bits at a time you want to store that particular thing, then it is called as 1 nibble. Likewise, if you want to go for 1 byte, how much it should be the 1 byte? It should be 8 bits. If you combine 8 bits, if you want to store that particular information in the programmable logical devices, then we can say it's a 1 byte. Likewise, we do have 1 kilobyte. It's how much? 2 power 10 bytes. 2 power 10 bytes how much? 1024 bytes is equals to 1 kilobyte. Clear? So likewise, we do have 1 terabyte, 1 gigabyte, like that. It's keep on, penta, everything is keep on proceeding. So these are nothing but the capacity of the devices. So basically, whatever the data we do have, it is going to be stored in 2 forms. One is the RAM, another is a ROM. So what is RAM stands for? It is random access memory, which is going to store the data in terms of read and write operation. What is the meaning of read operation and what is the meaning of write operations? So we should know read operation and we should know what is the meaning of write operation. So write operation means you had the data, you just want to insert into the memory. So when we want to write something, that means we are inserting the data to the memory, then that particular thing is nothing but the write operation. So when we are inserting some data to the devices, when you just want to add some data inside the memory, those particular things come under the write operation. Then what about read operation? Read operation is retrieving back. You already store the data, you want to read out that particular thing again, so then it is called it as read operation, right? So random access memory can perform read write operation. Where they'll store, there has to be one particular address, there should be a one particular location, they should also have some address. So that means to store a data we should have read operation, write operation, there must be a address bits must be present in order to store the data into the particular location. For that particular purpose we are going for these all things. So students, so we just want to write the block diagram of that memory element. So basically what we discussed that memory is a device which is used to store the data. It can perform in two particular operations. One is the write operation, next is the read operations. So what is the write operation? When you want to insert the data, when you want to store the data in the device, then that particular thing is nothing but your write operation. So writing should be done from device. We just want to store. For when you are storing any data in the memory, then that particular thing is completely considered to be the write operation. Similarly, to get the read operation, so to get read operation, what we are doing, we are retrieving back the data from storage purpose. For that particular thing, what we are just want to write, we just want to retrieve back. When already we store it, we want to read it. That the way you can say that. So when you want to retrieve back the data from memory, then that particular thing is considered to be the read operation. So write and read. So in order to do these things, what is required? There should be a storage location, right? So when you want to store a data into a particular location, that point is considered to be the address. So address means the points or the bits where you want to store the data. There must be a particular address, right? When you had your memory address, you may have, when you see in computer, you want to store a data in a particular drive like C drive, D drive, E drive or desktop somewhere. That means we know that where exactly we just want to store the data. That particular thing is nothing but like location or address. So in the same way, when you want to write the data or when you want to read the data, when you want to store some data, there must be an address. So in order to perform these two particular thing, what is required? Address is essential. So we can say that to perform write and read operation, address must be there. So let us see how the memory unit block diagram is there. So memory unit, we just want to write its block diagram. So basically we just want to write what are the things is required for memory unit. So what we are doing, we are taking one device, one particular block we are taking, and what are the three things required for it? One is, you can, first basic thing would be you want to write or you want to read it. So for that what we'll write address line, then we'll go for read write, right? So what we are doing first is, suppose we want address, so address line. Next, after address line, what is next to required? Write. Then next would be read. So you're done with write, read, right? So next thing what you have, you had the memory unit. So memory unit depends upon what are the combination? 2 power n, right? As we have seen just now. Whatever the data we took in the previous one, it's completely depends upon 2 power n combination. So what is that 2 power n combination? Depends upon the size of the memory. So based upon the size of the memory, it is going to write that particular thing. So how much words it can have? 2 power n words, where n bits per word. So this is nothing but 2 power n words it can store. Each storage is n bits per second, right? This is the capacity of storage of the devices. So next thing, we just have to write the n data output lines, n data input lines. So because we want to store some data, so we just want to write it down, n data input lines, because we want to insert data. So when you want to retrieve back the data, what we'll write? N data output lines. So this is the way you can say the block diagram of your memory device. So what it consists of? It consists of first basically address line, then for writing operation there should be an input data lines is coming over here. So from there whatever the bits we do have, it is going to be considered as input to this particular device. That is, suppose this is your ROM or RAM, that is nothing but PLD. PLD is nothing but programmable logical devices, where you did some programming in that, you want to store the data in that particular location. In order to do this thing, we just have to write that into input lines. So this is your input lines. It can be n. What is this n indicates? 2 power n words can be stored in n data input lines. That will be depends upon this. Suppose I am assuming this is your k letter, this is a k. They are k address lines. Then that is a write operation, read operation. After getting this all, what you want? You want to retrieve back. When you already had the memory, you insert the memory data in that, you want to take it back from that. What we'll do it? We'll take out from n data output lines. So this is the way your memory unit is going to be work. The next thing what we need to see, students, how do we write the conventional symbol and array logic symbol for different gates. So for that what we need to see, so basically what we are doing, we just want to write any gate you want to see. In this we just want to represent the inputs into different ways. Suppose OR gate, if you want to write, what we will do, we will write OR gate like this and we will mention inputs in this way. So this is the way it can have n number of inputs. This is a conventional way of designing. If it is array, what is the meaning of array? Collection of your inputs. In this particular thing what we are discussing is collection of inputs. For that what we will do, we will write the symbol in this way. So the same OR gate we will write, and instead of these whole multiple things we will mention one line that indicates multiple values. Likewise we will represent. This is the way of representing array symbol for OR gate. For OR gate. What about this? This is your conventional symbol. Conventional way of representing OR gate. So this is the way we will modify it. What we are modifying, instead of these all multiple inputs, we will mention one inputs and we will put a vertical lines. But if you had the connection in this, that need to consist of one circle like this. If they don't have any particular connection, only we will mention and we will put a cross mark over there. That indicates it's an array. Array means having n number of inputs value only passed to a single input particular thing, then it is called array logic symbol. These two symbols you should have to be familiar with it. This are we using in normal designing. In memory element designing we are going for this array symbols. These array symbols are used for PLDs. What is PLD? Programmable logic devices. In that it has two things. One is PLA, next is PAL, then we do have still CPGA and FPGA, CPLD. These are the devices we are going to use. What is PLA stands for? Programmable logical arrays. PAL, programmable or array logic, right? Likewise we do have FPGA. This is also one of the type of gates. We are using one particular gates IC. In that how these particular symbols are going to be used, that we are going to see. So this is field programmable gate array is there, then complementary programmable logical devices. So this is the things we need to design it by considering these all memory concept into mind. So what is the memory concept is all about? When you had any particular inputs value, it should be done based upon two operations. One is write operation, then read operation. So basically write operation means what? You want to insert data into the memory elements, you want to store the data. So for storing or for inserting data, then that particular thing is considered to be the write operation. Then what is the read operation? Retrieving back, taking out the data. You want to read out, already you store it, you want to take out the data from it, then it is called read operation. In order to perform read and write operation, there must be a address lines, the location where you have stored the data, that must be known. Doing all these things, we should have PLD, programmable logical devices. We will take different example of it by taking the combination. So by taking that, we will see now how it is going to be work for different programmable logical devices. So it's quite not visible. Now see, PLA stands for Programmable Logical Arrays. PAL stands for Programmable Array Logic. Like we do have FPGA. Then we had CPLD. So these are also the type of, we had programmable logical devices for storing the memory. Now let us take one example, students. So we are taking example of content of 1024 into 16 memory. So this is an example we have considered, and we need to write how the storage is going to be there. For that we just have to write the memory elements, how the memory is going to be stored. For that what we will do, we will try to write down what is this thing. 1024 is, this is nothing but your storage capacity, how much they can store it. And what is this 16 indicates? This indicates it's a content, each location content how much. So this is nothing but memory content. What about this complete block? This is your addresses. You're giving addresses, right? What is required to store memory? They require three things. One, whether you want, first thing has to be address. Here I will write, first thing will be address. Second thing is whether you are going for write or read operation, right? So in order to do this, we should have one control also. So this thing we required to go for inserting the memory or retrieving back the memory. For that what we are taking one simple example, 1024 bit. So this is the byte we do have into 16 bits. This is a bit size. Suppose I am having, what is the first decimal number? 0. This is my first location. Likewise I do have, how much I should have? Suppose I am taking 2-3 example, 102 1, 102 2, 102 3. Total how much? 0 to 102 3, it is 1024 locations. These are the locations. So how much it should have? Address lines 2 power 10. 10 means, what is the first binary combination? All 10 times 0. 1 2 3 4 5 6 7 8 9 10. The next would be 1 2 3 4 5 6 7 8 9 and 1. Likewise I do have last is, till last I can write 1 1 1 1 10 times, right? 1 2 3 4 5 6 7 8 9 10. Likewise I do have these all numbers. So what I'll do it, I had the binary form of this address. That address indicates a binary combination. Whatever is this decimal number, it's a location where, at what location what information you had. What about this 16? 16 indicates the bit size of this one. I'm storing any random bits. I'm taking 16 bit, 1 0 1 1 0, anything you can put it. How many bit size should be there? Size should be 16. So this is my first location, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. This is my first information, because whatever you store it, whether you had pics, whether you had a video file or audio file or any document, all the things computer will convert into binary form, right? That's how much is the size of that particular each location? 16. Likewise I can go with second part also. Here also it can go for storage of 16 bits. Any random bits I am putting, but size needs to be 16. So 1 2 3 4 5 6 7 8 9 10 12 13 14 15 16. Likewise I can put anything which I just want to store it, data of that particular thing, and the size needs to be 16. Likewise I can store any random thing. Why I am putting random? Because any data, when they want to store it, it take that particular value. So by taking this particular thing, it is going to store that particular data. So what is 0 and 1 indicate? This is nothing but this computer can understand either 0 or 1. Whatever data we will pass to the computer, whether it is audio, video or any particular thing, that will be converted into zeros and ones. This is the memory content. Each content should be a size of 16. And then 1024 indicates the addresses of that particular would be how many bit size? It should be 10. So the size of these particular bits are 10 bit size. Right? And how many address locations? From 0 to 1023, that indicates it's of 1024 address. Clear? So this is the way your memory is going to perform, whether it's read or write. So basically what we are doing, we are writing, right? We are inserting data to the memory, because I only have mentioned this all zeros and ones. For read operation, already I have stored it. I want to read out this thing. That is done by the ROM, right? So basically ROM also have different types of it, RAM also have. So RAM consists of two types basically. What is that? Static RAM and dynamic RAM. What is the static and dynamic, and how it is going to be used, and what are the things we do have like PLA and PAL? What are those things? Internally how it is going to be go for designing part by taking the logic gates. We are going to see in complete designing part in the next class. For today's class you have to see this particular thing, how it is going to work and what is the meaning of memory. So basically memory, in that we have taken one example and we discuss about programmable logic device, where it consists of two particular things. One is the selection of the conventional symbol, then logical array symbol. So in conventional symbol normally will give number of inputs as it is, but in array logical symbol will give one inputs and will give vertical lines. That vertical line indicates what? That indicates how many inputs you are going to give. Array is nothing but collection of your inputs. So based upon these two things, we are going to see in the next class how do we design by using ROM. So ROM also various types. We had EEROM, UVROM, PROM, there is a programmable read-only memory. All those things we do have, we will see in the next class. In today's class, we just only see one example, and this is also they can ask you for designing. Just designing means they'll give the size 1024 into 16. You have to write this particular thing, write the memory content, decimal number and binary. Binary indicates this 1024 is nothing but 2 power 10. 10 bits, all addresses needs to be 10. Like if I do have 1021, 1022, that also should be in 10 bits. This decimal number representation, because 0 to 1023 total is 1024. The 16 is size of that particular thing, and that's how we can write it down. Thank you.